customer's journey to mainstreaming the mainframe. Before we begin today's presentation, there are a few housekeeping items that I'd like to share. Today's presentation includes a slide deck along with screen share. The slide area can be maximized by clicking on the maximize icon in the top right corner or by dragging the bottom right corner of the slide area. To ensure an optimal viewing experience, please ensure that you have checked system requirements along with bandwidth considerations. If you have any technical difficulties, please click on the help link located via the question mark widget at the bottom left of your screen, where you will find details about system requirements and frequently asked questions. If you experience a blank screen during the demo, please try refreshing your browser, as there may be a brief delay when the screen share starts. To ask questions during today's presentation, please type your questions into the Q&A widget and hit submit. We'll answer as many questions as time allows. Also, notice the Learn More widget. Here, we've added a copy of today's slide presentation along with some additional content, including our Mainstreaming the Mainframe white paper. We also encourage everyone to fill out our survey before the end of today's presentation, and by submitting your response, you will automatically be entered to win a $50 American Express gift card. Once again, if you have any technical difficulties during today's presentation, please try refreshing your screen or click on the help link located via the question mark widget at the bottom of your screen, where you will find details about system requirements and frequently asked questions. We are extremely pleased today to have as our speakers Director of Information Technology at Ameritas, Mike Wells, SonarSource CEO, Olivier Gaudin, and Compuware Product Manager, Steve Kansa. With that, I'd now like to welcome and hand things over to Steve.
Thanks, Janet. I'm really excited to have the opportunity today to talk about Compuware's approach to mainstreaming mainframe application development. We believe it's critical for companies to thrive in a digital economy today to have a single, modern DevOps culture that allows them to learn and grow and improve their capabilities to deliver business value. A key thing to bring about this type of culture is embracing best-in-class tools and processes that can be used across the technology stack. I'm thankful today to be joined by some of our partners in this journey, Mike Wells from Ameritas and Olivier from SonarSource. I'd like to ask Mike to talk a little bit about his background, since he has a unique journey for involvement in mainframe application development. Mike, can you share a little bit about your background?
Absolutely. So thanks for joining. My background is probably 70 to 80% Java, and let's say 20 to 30% mainframe. I started off my early career working on mainframe, supporting mainframe applications in the mid-90s, late 90s, and really became a full-stack developer throughout the 2000s and late 2000s. As I progressed out of my last company into Ameritas, I took over responsibility again for essentially all of our software development. That includes packaged applications, Java, and mainframe.
Thanks, Mike. So as customers start moving towards embracing tools, process, and culture that can take advantage of business opportunities, we found that there are several key milestones in the journey. Today we're going to talk about some of those: modern Eclipse-based interfaces, continuous integration processes, and automated code quality metrics. Now I'm going to turn it over to Olivier to talk more about SonarSource and their unique approach to managing technical debt and quality metrics.
Thanks, Steve. So really the thing I want to talk about first is about the fact that managing technical debt is not a new problem, but it's a problem that has been around for many, many years. And we think that with our approach, we can really make a difference. And obviously, after that, Mike is going to talk on how we can apply this approach to some, I would say, pretty unlikely area. So first, I want to introduce a little bit SonarSource. SonarSource, we are really the de facto leader for code quality. We have an open source model, which means that part of what we develop is open source. It's about 75%. Part of what we develop is commercial on closed source. Today, there are more than 75,000 companies that use our products, and we have more than 700 customers that use our commercial products. Our solutions really target large and very large corporations. We currently have half of the Fortune 100 companies that are our customers. As I mentioned before, we have our solutions are made of two main products. One is SonarQube, which is really to have an enterprise approach to code quality. It is pretty popular product. As I mentioned, 70,000 installation worldwide. More than 70% of Java developers use it daily, and Java is really where our solution is popular, but we are also delivering it on other technology. SonarLint, on the other side, is a product which is more developer-centric, and it comes in the IDE. This is the second part of our solution. So really, and we deliver this over 20 languages. So the very first thing I want to talk about today is what problem are we trying to resolve. The problem we are trying to resolve is really the fact that when you write code, source code today, you are going to have to maintain it tomorrow. And if you are not careful, this is going to be costly. If you deliver code which has bad quality, tomorrow you are going to have to pay a little bit more. This is this is compared to we call that technical debt, and it's actually a metaphor which is made with a financial debt. If you want to buy an apartment today, you most probably are going to have to do a mortgage, go to the bank to do a mortgage, and then you will have to repay the mortgage and some extra interest. In the same way, if you want to ship to production today and you wait to have the perfect quality in your application, you are going to have to wait forever. So what we are saying here is that you should borrow a little bit. So basically, you should accept to have some technical debt, so some non-quality, and you will pay interest later. So basically, you need to do two things when you want to ship to production. One is you need to be aware of the technical debt that you have. That's point number one. And point number two is you need to be ready to deal with the consequences. If you ship some complex code today, you know that whenever you will want to change it, you are going to have to pay a little bit of extra. Extra time to read code, extra time to change code, you are going to have to be extra careful when you are going to make tests, because you know that this area of the code is a bit smelly. And then comes the challenges when you want to adopt a practice of code quality within an organization. If you have a traditional approach to code quality, which is basically that once you are done with the development, someone is going to review your code, is going to make some assessment whether it's good code, bad code, and is going to come up with an action plan to remediate this code, then you are going to have several challenges. First of all, this is going to come too late. Whenever you do a project, very often these projects are late, and whenever the development is going to be finished, everybody is going to want to push the trigger and to go live. You don't want to wait and do some reworking. So when you do this code quality at the end of the process, it's generally too late. A lot of teams, a lot of developers are going to push back on this. They are gonna, they are gonna not want to make the changes. They will, they will declare that they are working on more important things. They will declare that code has changed already, etc. So there will be pushback. So if you think about it, there is kind of a lack of ownership in this process. Who really owns quality in such an environment? Is it development or is it QA? Is it both? I tend to consider it's none. One of the points which is very, very important for us, and I think Mike is going to mention it later on what they have done on this, is in order to have a code quality practice in an organization, you need to have a quality gate. A quality gate is the set of requirements that you are going to go through, that your application is going to go through before you can ship to production. If you do not have a quality gate, so if you do not have this set of requirements which will tell you this is fit for production or not, we tend to consider you do not really have a code quality practice. It's going to be a best effort. Some people are going to be good at that, some people are going to be bad, but as an organization, you do not have a practice. And to see this quality gate, when you are in a traditional approach, it's actually very, very difficult to find consistent requirements that you can share amongst your organization. We at SonarSource, we really think that we can change this gate. And to change it, there are 4 pillars we think should be applied. First of all, development teams, they should own quality. This is a no-brainer. It should be, code quality should be a deliverable of the development team. The second item here is the feedback loop should be short. You don't want to wait, 2 days, 3 days, 1 week, 3 weeks, 3 months, 6 months to start improving quality. This should be done as you go along. The third very important point here is quality gate should be unified. This is very, very powerful to have a unified quality gate across an organization, which means that you have a set of 3, 4 criteria that make quality in your organization. Everybody shares the same. Everybody can discuss that. It's not on a per project or per team basis. On the last point is that the cost should be non-significant. It shouldn't require any special effort to adopt this quality practice. So things like for 2 weeks or 3 weeks we improve quality, or we have a dedicated team to do that. We don't really believe in this approach. It has good results in the short term. It doesn't in the longer term. If you do that, you can, you might be able to have a little bit of fun in managing code quality. So how do we do that? Our proposal to do that is really to fix the leak. We compare that to managing a water leak, basically. When you have a water leak at home, the first thing you want to do is to fix the leak. If you don't fix the leak, anything you can do is going to be a waste of time. So the very first thing you want to do is stop the water going onto the floor. And if you compare it to code quality management, the very, very first thing you want to do is to make sure that the new code and the change code is under control. This is the leak. This is the very, very first thing you want to do. And if you do anything else than making sure the new code has good quality, it's basically a waste of time. It's only a matter of time before you're going to be back to square one. Then once you do this, all the challenges I mentioned before, they are not going to be challenges anymore. First of all, new code, you can check it as you go along. You are going to have quick feedback. You don't need to rework. You are going to just fix problems as you go along. Developers are not really going to push back because they are responsible for what they have just done. So it has a much easier adoption. And the other very, very nice side effect of this is that you are actually going to reimburse your existing debt. Why? Because by nature, you keep changing software. So I think industry numbers said that in organization, we tend to change about 20% of our code base every year, which means that after 1 year, if you put your new code under control, you are going to have 20% of your portfolio which is under control. After 2 years, it might be 30, 35%. After 5 years, it might be 50%. So think about it. You're going to have 50% of your code base which has good quality. This is enormous. And if you think about it, the 50% which is not under control is going to be the 50% which has not been changed in the last 5 years. So this is really the 50% where you don't, in terms of priority, it's not the highest priority. It's probably lower priority. And the last thing I want to mention here is the fact that many large organizations have already adopted this approach of code quality, which is simple and very efficient with quite big success. Ameritas being one of them. I'm now going to pass it to Mike.
Thanks, Olivier. So again, this is Mike Wells. We use Sonar and the whole host of tools we're going to talk about really to, make our dev teams more awesome than they really are. So we'll start off with the how we actually got here on this journey. The first thing we did when I got here, so I've been at Ameritas about 2 years. The first questions I started asking, it wasn't really COBOL-centric or mainframe-centric. It was around every application that I had. How many applications do we have? How many lines of code do you have? And that's an interesting question when it comes to COBOL. When you start asking your teams, you start to become frustrated because you don't know. Do I ask, a developer, the manager, my infrastructure operations team, a vendor, how long does it take to get the answers for how big your code base is? Are the numbers right? They're constantly changing. So I started off just being frustrated because I couldn't get the answers around my entire ecosystem of products that I owned. The other piece there is really just domain nomenclature around naming conventions. And, our developers, they have an incredible memory for, what are the names of the files, the programs, whether it's, POL1234.COBOL, 12346.COBOL. Those mean everything to a developer, but as you try to assemble that back and relate it back to something meaningful outside of a developer, it doesn't mean anything. It's domain knowledge and becomes frustrating trying to decipher really, what does that program mean? What's it part of? Is it part of a product? Is it part of a bigger application? How many lines of code is it? Are there issues with inside that piece of code? Is there duplication of code? You don't know. And when you have thousands and thousands and thousands of those files, you literally need almost a spreadsheet to keep track of what does that file mean? What application is it? Or what part of the ecosystem is that? So where did I go? So, I started off just being frustrated, just not knowing across the ecosystem. And this wasn't just COBOL. This was everything that I had. I didn't have visibility into, how big was my code base? How many applications did I have? What was the rate of change? So, I brought the right stuff to the table. I started off with Jenkins, and I used Jenkins to do many things inside of my product space. It goes and gets my code, whether it's Java, whether it's COBOL, whether it's web technologies. Jenkins is the orchestrator of my code. And then I bring SonarQube to the table. It's continuously inspecting my code, regardless of the language that I have that I'm writing. And whether it's COBOL, Java, PL, SQL, CSS, HTML, it inspects my code. And, we're using the Compuware products with their integrations back to our tools to make our COBOL tools even cooler than they already are. The other piece to talk about is how do these things fit into the life cycle of my environment? From a development perspective, we have Eclipse-based IDEs, whether it's from a Java perspective or, web perspective, now even COBOL with Topaz. I have the same development environment with the same integrations back to all of my products. So we use Jenkins and Sonar and Gradle for our continuous integration environment from a Java perspective. It's doing our application builds or deploys to Sonar or deploys to our dev servers for just deploying our code. It's doing our integration tests for us. The cool thing there is I use the same thing for the mainframe to push my code to Sonar. From a code review perspective, we're using Sonar again across my entire product base, regardless of the language. We're using Sonar to not replace code reviews, but to supplement our code reviews. And I'll turn it over to Steve really quick for a demo before I continue.
Sure. Thanks, Mike. So let me give a second for my screen to share. So what I'm showing here is Topaz Workbench, and Topaz Workbench is our Eclipse-based IDE, and it allows you to integrate your mainframe development into a modern interface. So you can see here it's connected into Compuware's mainframe development productivity suite, and it allows me to see my source. So in this case, I've grouped my source for a monthly sales application together into a project. And on that project, I'm able to configure SonarLint to run. And what I'm showing here is SonarLint 2.1, which is the latest release of SonarLint, and it allows you to connect back into SonarQube to get a rule set for a project to run against. So it allows a developer, from a developer perspective, to see as they're writing the code what potential issues might exist. So let me give you an example of what that looks like. So in this case, I've modified an application to include some additional regional processing. And during that modification, I can see here that SonarLint has detected an issue. So I'm able to see that issue in the code. I can click on the issue, and I might not be really familiar with what rule I violated. I'm able to get help on that issue, so I'm able to understand what's wrong with the issue. I can see examples of non-compliant code, and I can also see examples of how to fix that. So now I'm able to go back into my code and very quickly jump to a place in the code where I can determine that I need to increase the size of this field. I can save it, and instantly I can see I've addressed that issue. So that's how this process of SonarLint directly in a developer's IDE allows you to shift left your quality process to right to the point of the code being written versus issues coming up later in a code review or possibly a test environment, or worse yet, in a production environment where someone has noticed a data truncation or data corruption. So the next thing I'm going to show is the continuous integration process that we've also enabled. So what I'm showing here is Jenkins, which is the leading open source continuous integration tool. And what we've done is created a plugin for Jenkins that allows Jenkins to communicate back to mainframe source control repositories. So you can see here the Compuware plugin is installed on this Jenkins server. And with Jenkins, I can configure a variety of different CI processes, continuous integration processes, to run against my different applications. So here I'm showing, again, the same monthly sales reporting application. I've configured a CI process for that. And with the plugin that we've published, I'm able to get at the source for that project, the same source that I was just looking at in SonarQube, and configure this process to run on a continuous basis. And when this runs, it pushes metrics back into SonarQube for that project. So I can understand, not just from an individual developer's perspective, but from a team perspective, where things stand in terms of potential issues in my code. And I can look at this across my technology portfolio. So in this case, my monthly sales reporting application may be a COBOL application. Maybe these other applications are Java or .NET, but SonarQube is giving me this holistic view where everyone can follow the same process, look at the same types of metrics and the same tool set to understand where things are from a quality perspective. So now I'm going to turn it back over to Mike. And Mike, if you can, talk about how this process has been ingrained in your development organization and some of the benefits you've seen in that.
Sure. So I'll continue here to where did we go? So one is we started off by being incredibly flexible from an organization, even a dev team. You know, when we started down this path, the tools didn't exist, the processes didn't exist, so we had a lot of trial and error and a lot of, I would say, just working through the process to get it to work. And the first thing we wanted to do from a team perspective is create what we call the global product dashboard. So by default, you push, from a COBOL perspective, you can push files into Sonar, and those files were, again, it's like that POL1234.COBOL 12345. So the problem I saw with that was, there's tens of thousands of COBOL files in our environment. How do you create a taxonomy around that, around not just an application, but a product? And what you'll see here is we created that taxonomy for, let's say, I've got a policy administration system. And what I did was I created that taxonomy of here's your policy admin system as an example, and I created a view for that. But then I created the view of the applications within that, essentially, policy administration system. So I created a product CIO level dashboard for what does my policy administration system look like. And this is, of course, all mocked up. So then I created the taxonomy for the applications. For example, what does my base policy processing application look like? This is how many lines of code. I've got a billing component. I've got, let's say, a reporting component, web services, correspondence, rates, and things like that. So I created a product level dashboard, but I'm able to show my application level view within inside that to say, what does my entire portfolio look like? But it gets even cooler. So again, we talked about, I was able to aggregate, let's say those, for this example, 106 files, but it's realistically thousands of files into my product level view and create one simplistic view. The other cool thing there is I'm able to look at what is the quality of my product. And this is a view as well that you can look at. How many blocking issues, criticals, bugs, security vulnerabilities, code smells that I have, all within one view of the entire product, not just a file or an application, but a whole product. And then you can also look at what is the rate of change. So within my product, can I say that we're getting better or worse? And I can measure that over time. So over a period of time, I can say, am I decreasing the amount of code smells or vulnerabilities or security violations that I have, or is it getting worse? And again, you can do that from a tag cloud perspective, which is down at the bottom where it says issues tag cloud. I can look at what are all the performance issues that I have in my code base. I can click on that, and it'll tell me literally by the program, by the file, where do my performance issues potentially lie, and I can drill down on them rapidly. Next, again, I wanted to show this because this is a tool that's not just for COBOL. This is a tool for your organization. And we manage all the applications that we write from a language perspective outside of, packaged products that we buy, whether it's COBOL, whether it's Java, whether it's C#, PL SQL, JavaScript. We have rules embedded and processes embedded for our entire ecosystem of our products, which is very cool. The other piece to show is what is your application level drill down. So if I have an application, for instance, and this is a mainframe application I mocked up here is, let's say, for correspondence. So within that product level view that we had before, I have the ability to drill down within the application. And from an application perspective, it's really important to define quality gates. And this is a very generic version of a quality gate, but you can define many, many instances or rules for your quality gates. And those are important because those are things from a dev team perspective or a management team perspective that you don't want going beyond development. So again, as Olivier mentioned, development owns code quality. It's not just a QA organization. Everyone really owns it, and it starts with dev. And here, is an example where I don't want a blocking issue or a critical issue or maybe even duplication of code. I don't want things being pushed beyond development that we're writing. So I can say, since the last analysis ran, for instance, we don't want these type of issues pushed beyond dev, and if they do, we fail the quality gate. And that'll go back into your code review process saying, if you get into the code review or the release management process, you fail that process, saying you can't deploy beyond dev if your quality gate's violated. The other thing that's really cool is I have the ability within, let's say, that correspondence application to look at what does the entire ecosystem of bugs, vulnerabilities, or code smells look like, or even duplication of code and beyond. And you'll likely have had a product like this correspondence application, for instance, that's mocked up. It may have been in production for 20 years. It may have a set of vulnerabilities that you just may have to live with. But you can get the view of what's out there. Now, what's really important is what has been introduced since the last period. So this is your leak period. So what are the new vulnerabilities that I'm potentially introducing from a code smell, from a vulnerability perspective, and I can look at that and quickly see and then drill down on those. And again, every one of these things are clickable and drill downable to the next level of detail. And this is just a mocked up version of what that drill down look like. So if I have a set of bugs here, I have the ability to drill down on those bugs and look at potential vulnerabilities. And it'll say, all right, here's all the instances out there that I'm trying to push a field that is too big into a field too small, for instance. That's very important. And you'll see that with that, I could drill down into it. And I'll go back really quick. If I wanted to, I'm not going to do this because I don't want to expose my real source code. I could click on this button right there, and it would actually take me to the exact line of code that's having the problem that's being violated, which is really, really incredible. The benefits, to my organization really are, we're a lot less likely to deploy software defects. A ton of team standards have been created because of this, and they constantly are reviewed and challenged and talked about across our dev teams. The other piece is it's duplication of code, and this is one I'm going to spend a few minutes talking about. If you think of traditionally from a mainframe perspective, you're working on a file or a program. It's that that POL1234.COBOL, and traditionally you may have some duplication of code in there, but it's probably pretty minimal. The opportunity by organizing this into a higher taxonomy of applications and products are, from an application perspective, if you define your product of correspondence, you may have 300 files that are out there that each have 10,000 lines of code. If I look at that from a correspondence application, for instance, or a billing or base policy processing application, and I aggregate those, let's say 150 files, 200 files together into one view, you may, if I looked at it from a one file perspective, I may have 1% duplication of code. But if I aggregate those files together into a much higher taxonomy of an application of, like, let's say dividends or rates, I may have 50% duplication of code or 60% duplication of code. And if you think that, let's say those 200 files each have 10,000 lines of code, that's a lot of code. And if it's 50% duplication of code, it probably took years and years and years and years to build that code. And then you talk about maintainability of the code. How do you maintain it? How do you upgrade it? How do you test that? And there's a tremendous opportunity by looking at it from this lens to say, as we write new code, as we enhance this, is there a way to better streamline our organization, our code, and reduce the footprint of code that we have and make things simpler and faster and cheaper? And that's really where we're at right now is we're looking at it from those lenses, which are just providing incredible visibility to our organization. The other thing is, we talk about just visibility. I think historically the mainframe is probably been perceived as more of a black box. Not a lot of visibility into what's it look like from a code quality perspective. What's it look like from how big's your code base? Are there duplications? You really don't have that. And I think from a duplication perspective, it's pretty impressive because you have the ability now to call it, not just duplications of code, it's dead code that's out there. And traditionally, at least in our organization, we have a tendency to pick up a program and clone a program to make it fit, the next set of requirements for another application we're going to go build. And with that, a lot of dead code gets left behind. What's cool about these tools and these processes are immediately at the developer's fingertips are the ability to see that they're leaving dead code behind. And that dead code, it adds to technical debt that you have to deal with at some point in time in the future. Whether it's a year down the road or 2 years or 5 years, somebody's going to look at that code. And if it's 5 lines of code, maybe it's easy. If it's 1,000 lines of code, it may get a little tougher. If it's 10,000 lines of code, it's going to get even tougher. And these tools just provide us the visibility to become a much more lean dev shop. And it's been tremendous for us. And my team has been incredibly flexible to help introduce these tools and be part of spinning them up. And, we've gone through a lot of trials and errors to get there. And I think we're now at a really good place with moving into the future with the tools. The other piece is, it doesn't really replace a code review, it supplements a code review. So, what I want to make sure people don't take away is this eliminates the need for code reviews. What this does is it supplements a code review and it gets the team on the same level playing field that we're all writing code the exact same way. We have visibility, and you don't walk into a code review saying, dude, what the heck are you doing in this piece of code? Like, oh my God, this is insane. This is insane. It takes that out of the picture. So when you actually walk into a code review, you start looking at functionally how does your code perform against the requirements versus talking about you're not following my standards and why are you doing it this way. It kills that. So just another important aspect to point out. The other piece that really I think you can't shy away from is just the cultural changes needed to implement the products and the processes. And I want to talk about what the good, the bad, and the reality. The good is we now have team-wide acceptance. The team likes it. We use it. I would say the bad or the reality is I had some probably shortfalls from rolling this out where I started with my Java team to spin it up because I knew it would be easy to orchestrate the whole continuous integration code analysis process with Java because I'd done it for many, many, many years. And we spun it up rapidly and worked through a team to optimize the stuff. But where I failed was, if I look at my distributed teams are in and out of technologies all the time. And they can assess and evaluate them, at least from my experience, they can assess them and evaluate them more easily. And, I spun it up and, when I introduced it to my mainframe team, I think I probably spent, 30 minutes, maybe an hour with my mainframe team and sort of tossed over the wall and said, have fun. That's the wrong approach. And, I sort of let them flounder. And, I assumed that, hey, they're senior mainframe developers and they'll pick it up and run with it. And I didn't spend enough time there. So I think, looking back, that there's an opportunity if you go down this journey, there's the truth is, start where it's easy to adopt. And I started with my Java team. My Java team spun up the tools, but we mentored the mainframe team. And I think the cool part there is that mentorship and partnership between the Java team and the mainframe team created really just a great working relationship between the teams. And I don't think you can do it without having a relationship between the teams. And if I had to rewind and do it all over again, I would have spent more time with my Java team, myself, and mainframe team talking through the intricacies of, Jenkins, the plugins that we had created, and even how to, use Sonar, how do we use it from a Java perspective, and just going through more demos and I would say tutorials of, here's how we use it in this space and here's how we apply it to this space. That's just my lesson learned. Where we're at now, we're optimizing the tools. We're finding different ways to leverage them to continue to enhance our dashboards. And we're actually dropping our technical debt. In one of our applications, I won't even tell you the language, one of our applications, in 6 months we took about 300,000 lines of dead code out of our application footprint. We've dropped probably 80% of our vulnerabilities out of specific applications, and we're continuing to drive optimization and make our teams better. Steve, I'll turn it back over to you.
Before we start answering your questions, I'd like to again encourage everyone to fill out the short survey to be entered to win a $50 American Express gift card. And with that, let's start our Q&A.
All right. We have a question about the quality gate functionality that was mentioned, and either Mike or Olivier could take this, but Mike, maybe you could talk a little bit about quality gates in your organization and specifically what software they're defined in and how you leverage that.
Yeah, absolutely. So I'll be happy to take that. So quality of the gates, you define the quality gate inside of the Sonar platform, and it is very configurable. And I define them from a development perspective, saying these are essentially, I want an entrance criteria into my test environment. And the quality gate is saying, I don't want things leaving development until they pass a quality gate. And so I define them from a software development perspective as a dev team, and it's maintained within the dev space. And the goal is to create that gate saying, I don't want code leaving development unless the quality gate is passed.
Okay. And quality gates it's a little bit interesting because that's actually how we came to the point of having this webinar. Is we were, from a Compuware perspective, we were looking at quality gates and how we can best implement a solution that people could adopt. And through that discussion and working with customers like Mike, we realized that really the best solution we could provide is integrating with companies like SonarSource that have a very robust, very agnostic quality gate functionality. So that's it's definitely something that we learned through our Agile process, how to adapt to what our customers wanted most. So we have some other questions here, and this is a question I think for you, Mike. There's a question on where do you host your COBOL code?
Yeah, so where do we host our COBOL code? So right now we use Endeavor for our platform there right now. So from an integration perspective, again, we have Jenkins integrations back to our code repository.
Okay. And there's another question about, do you maintain your JCL in the same way that you manage your code?
JCLs are maintained and managed in Endeavor.
Okay. And there's a question about how does SonarQube or SonarLint handle large projects and large portfolios? Maybe, Olivier, is that a question you can speak to?
I'll take that as well. So how does it handle large projects? So it handles it pretty well, right? So I will say from a Sonar perspective or Jenkins perspective, however you want to look at it. So Jenkins is taking my code, orchestrating my code to Sonar. And from a large project perspective, I've had projects upwards of 600,000 lines of code pushed in minutes.
Great. So there's a question about is Topaz Workbench and plugin mandatory to implement Sonar in Jenkins for the mainframe? So I'll take that. So SonarLint is a plugin into Eclipse, and although it may be technically possible to get it to work with other Eclipse-based IDEs, we've taken steps working with SonarSource to make that experience as smooth as possible, and the integration just works. So from a SonarLint perspective, definitely Topaz Workbench is going to give you the best experience. From a Jenkins and SonarQube perspective, it is possible to use Jenkins in SonarQube without our plugin, but then it'll be up for you to figure out how to move source code over and manage that source code in that process. So early on when we were talking to Olivier about what we could do to best support a continuous integration environment and really mainstream the mainframe, that was one area that he said, Compuware, if you can really help make this a seamless process, it's really going to help the ecosystem and help advance the approach to mainframe source code quality. And Olivier, I don't know if there's anything else you'd like to add on either of those points.
No, I think you guys did a very good job to respond to this. I think that one of the key points is how can we make it fluid and easy to integrate these tools. That was a challenge that we had, and that was resolved with Jenkins integration, definitely.
We have another question on how to find the delta of code and find the impacted components and then execute test scripts in an automated way. So,
well, this, if I may answer this, this is part of the core feature of SonarQube, actually, which is that part of the feature is to We are not trying to find delta of code. We analyze the whole code, and as Steve mentioned, it's a pretty efficient product that we have. And then we will show you the impact of your changes, which is the main thing. The fact that you analyze all the code or part of the code doesn't really matter. What you want to know is what were the impact of what you changed. What problem did you add in your existing application?
Okay. There's another question on some of the metrics. So there's a question of, is there a McCabe or Halstead bug prediction metric incorporated?
No. We use McCabe cyclomatic complexity. So I suppose in the question here when we talk about McCabe, yes, we do use cyclomatic complexity, and we report it on. We have various algorithms depending on the language, on the technology. Halstead, we do not.
Yeah, and I can, I guess, add a little bit of commentary in terms of the SonarQube metrics. Is there is the capability, as Olivier said, to look at the complexity metric, but there's also, and Olivier, correct me if I'm not explaining this correctly, but there is the capability to set a threshold for complexity, and if your code goes above that threshold, it'll be flagged as an issue in SonarSource. So it's really not just generally looking at complexity, but looking at complexity over a certain threshold.
That's absolutely right. We do that in at many places. It can be done by program. It can be done at the section, paragraph level, whatever level you want to set a threshold on. You can do that. Indeed.
Okay, I think we have time for about one or two more questions at the most, and for those that we don't get to, we definitely will follow up. But Steve?
Yeah, there's a question on, do you plan to support automated testing framework for COBOL and Topaz Workbench and make code coverage available in SonarQube? And I will take that. That is absolutely in our roadmap plans to expand out and really try to address mainframe automated testing in a new way. There's obviously many different ways to approach automated testing, and I think we're going to have a solution that's unique in the market, and it will definitely tie together code coverage and kind of complete the life cycle and get COBOL code parity with code like Java or .NET in terms of tying tests and code coverage metrics back into a continuous integration process so that customers are able to monitor that code and put together a very robust automated code quality solution that allows you to move very quickly without sacrificing quality. And I think with that, I am getting the signal that we are out of time for questions. So as Janet said, we will definitely follow up for any questions that we didn't get to. And
yes, thank you very much. Yes, we will definitely be reaching out to those that we were unable to answer on the live presentation. Just a reminder to please take the time to fill out that survey. It will be very helpful to us in helping you as our customers. And with that, thanks for attending today's webcast. This concludes today's presentation. Enjoy your day.